Some science experiments today. Got a lot on tap for you today. We'll start off like we normally do. Doing some acid base experiments. Got a little base over here to this flask on the left. One drop. Let's see what happens. Let's give it another drop. Come on, baby. Looks like we need another one. That's pretty acidic, huh? Let's go a couple more. Come on, give me a rainbow. Come on, give me the rainbow. Oh, I added too much base. A little bit of a flash of a rainbow, I think. I just want to make this acidic. How you doing there, creator, hat creator? Welcome aboard. All right, let's try it again. Come on now. Let's see. Looks like nightfall, doesn't it? Ha! It's pretty cool. A couple more drops here. Let's make it acidic. I'm adding drops of acid. You can check the pH out over there on the... Well, there's a nice little rainbow flash for you. The pH values over there on the right. As I'm adding acid, of course, the pH is dropping, and now it's red, so that's acidic. Let's try adding some base. See if we can jack this up a little bit. Here we go. 2 drops of base. pH should go up. Boy, my base is quite concentrated, isn't it? I'm going to turn this down just a bit. Yeah, I added a couple drops of base. Looks like we're at like pH 8. I'm going to call it pH 8. Let's add a couple drops of acid. Bring that pH down. How you doing there, Future Farm? Welcome. Thanks for reaching out on LinkedIn. Good afternoon. Here we go. Give me a drop, see what happens. Not much. Looks like there's quite a bit of acid. Let's add another drop of base. This should increase the pH. You can certainly see that violet color grow in. Oh, look at there. We got some rainbow, man. You got it, Carlo. You're going to have to continue to remind me of that. That's a beautiful little pattern, flow pattern we got there, huh? A lot of color pattern there. Let's take it all the way up to, it's like pH 8. Let's take it all the way up to pH 10. I'm going to add another drop of base. Sure enough, look at that. Look at that beautiful violet color. Very nice. We'll pull it back down. Going to add some acid. 1 drop. Another drop. Let's add another drop. You can see where I've added acid, it looks red. And then as it reacts with the surrounding base, it looks like most of it's getting consumed by the base. There's an excess of base present. You can certainly see that red line there in the middle. You can tell that the acid that I add, it sort of stays focused in the center like that, because that middle region's a low pressure zone. I'm going to add another drop here. And material tends to stay in a low pressure zone. Hello there, guys. Welcome, guys. Let's add 1 more drop, see what we get here. Another. I think we got a rainbow flash. It looks like we're down to pH 8, and a whole bunch of stuff's going on, man. A whole bunch of stuff's going on. That was beautiful. Let's make it go all the way to acidic. I'm going to, look at that. That's pH 6, right? You can see the color chart over there on the left. We're at pH 6. I'm going to keep adding acid, like 3 drops. That should pull us down to pH 3. The nice red color. And now... Oh, that's cool, guys. Fan of the periodic table since age 6. So Future Farm, is it the equivalence point when it changes color? In this particular titration, you are thinking of a titration, and that we could be thinking about this. The way we would look at it is the reaction between sodium hydroxide and hydrochloric acid. So if this was indeed our titration up there at the top, these would be our reactants. Hydrochloric acid and sodium hydroxide. That's what I'm adding here, sodium hydroxide. Here's the hydrochloric acid. Right now we have an excess of hydrochloric acid, which is why the pH is low. When these two perfectly balance, you get salt water, which is neutral. So in this particular titration, if you want to call it that, we'd see a green color. Let's see if we can get there. I'm going to add a drop of base. And as I add that drop of base, that reaction I showed you previously is going to happen. The acid that's present neutralizes that base. You can see the base in the middle here. See that violet color there in the middle? It takes a while for it to spread out into the solution because that's a low pressure zone there in the middle of the vortex. So the material is going to tend to stay there. There's another drop of base. And you can see now the color is kind of shifted, right? It's gone from a red color maybe to a yellow-orange. And, of course, as the base continues to move through, we're going to see a bunch of other different colors. Yeah, I think we got it to a pH of 4 or 5. Let's add another drop of the base. Remember, this is the chemical reaction that's happening. Hydrochloric acid is in the flask. I'm adding sodium hydroxide, and that's neutralizing it. So right now we're at a pH 4, maybe 5. I'm going to add another drop of base and see what happens. Oh, boy. We got a bunch going on. Where's it going to land? We now have an excess of base. Hello there, Syed. Welcome aboard again. So now we've got an excess of base. There's extra sodium hydroxide. That's pH 9, yeah? We are definitely at pH 9, so there's extra base in. I'll continue to add base, and then the pH will continue to rise. Here we go. Let's add another drop of base. In it goes. And now we got to the violet color. Now we can run the titration in the reverse. Thank you there, user. I appreciate that. We're going to run the titration in reverse. And now the flask has an excess of sodium hydroxide. I'm going to add hydrochloric acid. Hydrochloric acid, by the way, that's the same acid that's found in your stomach. It's just the stuff that I add is a lot more concentrated. So as I add hydrochloric acid to this, hey, greetings, NL Kevin. Here we go. 1 drop of acid. The reaction's going to take place. We're making some salt water. We are neutralizing the sodium hydroxide that's in the flask. In the center of the vortex, it's acidic. That's why we got a red color in there. Better add another drop. It looks like all of the acid's been consumed. Let's add another drop of the acid. What's going to happen? Oh, it's taken a while, isn't it? So if you're curious as to why that red color stays in the middle, it's, you know, it's a low pressure region in the middle of the vortex. Just like the eye of a hurricane's a low pressure zone, so is the center of our vortex. And matter tends to stay in low pressure regions. It doesn't move from low to high pressure. It moves in the opposite direction. So you can see that red line there from the acid that I've added, the hydrochloric acid that I've added. When it gets down to the stir bar down there at the bottom, it gets pushed into the rest of the solution. And it looks like, man, that base is really, really concentrated. Let's add another drop of acid. I'll add it out here to the side so it mixes quicker. Oh, man. Yeah, we better add another drop of base. You can even see that it pulled it into that low pressure region. Hey, greeting there, Alberto. I do, Future Farm. Still, we better keep adding. There's another drop of acid. Kai's always wondered if Earth could pass through a gas giant like Jupiter in a collision course because Earth is a solid planet while Jupiter is a gas planet. That's an interesting question there. What's the stuff taste like? It tastes like a really rough afternoon because one of the dyes in here used to be the main ingredient in X-Lax. Looks like we're down to like pH 8 or 9, so we can tell finally, as I've been adding the acid, that we can see that the pH is going down. So let me go ahead and add another drop of the acid. In it goes. So our pH should go down a little bit. I'd say we're at pH 8 now. We'll keep going. Add another drop of acid. We're trying to get it to neutral, which would be a green color. I think we're there. I think we got pH neutral. Of course, there's other stuff going on in there. I see a line of red, pH 3. I see some yellow, pH 6. I agree, those are pretty. No, Pokemon, it is not. Isn't that crazy, Future Farm? It looks like we're just a little bit acidic at this point. Van Tran, what this is a vial or a flask that's full of water with some universal indicator. Over here you can see the different colors that universal indicator displays at different pH values, plus whether it's acidic or basic at those different pH values. And then what I'm doing, Laksh, is I'm going to add some acid to this. Hydrochloric acid, watch what happens. In goes 1 drop. Syed, it would be salt water at neutral with the exception, of course, that there's a dye in here. Well, there's 4 dyes, actually. And at least one of those dyes is not something you want to be drinking. I think we're down to pH of 4 or 5. Let's add another drop of acid here, and it goes. And now we are at pH 3. I tell you what, we're over 100 viewers, so now it's time to move over to the different experiment. So let's do that. We're going to move over to this experiment over here. In this vial, what I have is some fluid. You guys are going to love this. You're going to love this experiment. All right. pH is not necessarily bad or good. pH is just a measurement of how acidic or basic something is. Technically, pH is the measure of protons that are in a solution, H plus ions. This is how we chemists abbreviate protons. So acids donate these things, H plus ions. Here we go. We're going to add the same dye that's in this flask. Okay, this is a color changing dye. It changes in acid or base. We're going to add it to this bottle over here, okay? These are the different colors that, you know, the indicator dye will display at different pH values. If I could get it to stay. And let's go ahead and, curses, forget about it. You all seen it. It's the rainbow. Here we go. Let's add some of this indicator dye. Here we go. That's right, man. We got Science Live shorts, Talik. Here we go. Let's add some universal indicator to this bottle over here. And we're going to see what pH it is, okay? So these are the different colors. All right. Let's do it. Let's do it. Here's my universal indicator. It's a rainbow indicator. We're going to add just a little bit. Here we go. I'm just going to pour it in. You guys are going to love this experiment, trust me. Oh, look at that. Beautiful green color. So it goes in neutral. Universal indicator starts out neutral. But we're going to go ahead and mix that through the solution, and we're going to see what happens, okay? And then I got another surprise for you, so you're not going to want to miss this. Here we go. Science rules, Talik. Come on, baby. Here we go. Let's mix that thing up. That's looking kind of yellow-green to me. Yeah, that looks kind of yellow-green. So that tells me that our pH is like, you know, neutral maybe. Yeah, maybe neutral, maybe just slightly acidic. Now what we're going to do is I'm going to add some salt to this, okay? Absolutely, NL3. I do use sulfuric acid in some chemical reactions. I've got a video coming out where I'm going to be using that soon. It does look like Mountain Dew. You can even see the bubbles. Here, let's zoom in and see those bubbles. They're kind of pretty. Look at those bubbles, man. Just gorgeous. Simple things, man. Simple things just sometimes are pretty if you just take the time and look at them. Okay, let's add the salt. Remember, the same dye that's in this flask is in this flask. It's just that this is at a different pH. This is at pH 3, and this is like pH 7. Thank you there, 11 Gator. Appreciate that. All right, let's add a little bit of salt to this flask. And then I'm going to explain what's going on. I might even set it up for you. Here we go. This takes a little bit. Where's my funnel? It helps me out. Here we go. Up here at the top. And in goes the table salt. In it goes. Hopefully I won't make too much of a mess. It looks like a little color change there. That's because the table salt is neutral. It's going to shift it a little bit. Can I get it all in there? It's got it. Oh, no. It's up there at the top. Is it going to overflow? Let's see if this works. I'm probably going to have to add a little bit more salt. All right. Let's shake this baby up and see what happens. Thanks, sir. Appreciate that. 4470, I see ya. Oh yeah, Daniel, we got the word police here. Appreciate it, Daniel. It is a bottle. Am I a hand model? Come on, man. What do you think? It turned vegetable green, huh? Hello, Elia. I'm shaking it up. It's going to take a little bit. I'll know pretty soon if it's going to work. I'm probably going to need to add some more salt. Come on, shake it up, shake it up, shake it up. I got to shake it to get all the salt, as much of the salt dissolved as I can. Hey, how you doing, Elia? Hello, Sardier. Welcome aboard. While I'm waiting to see if that works, let's put a little bit of drop of base in our flask over here on the left. There we go. Yeah, it's not working yet. I got to shake it up a little more. Let's put a little drop of base over here so you got something pretty to look at while I'm shaking it up. Look at that color change, baby. Come on now. All right, come on. Let's get some more salt dissolved here. Shake, 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 shake. Shake, 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 shake. Come on now. Come on. People want to see it. People want to see it. Let's see if that's got enough salt dissolved in it. While we're waiting, let's add a little bit of acid. Muddy Mind, I'm showing how universal indicator changes color at different pH. We might be getting it over here. No, not quite. Not quite. Oh, look at that. Come on, baby. That's beautiful. Not quite. We still got to get a little bit more dissolved. Come on now. Come on now. We got pH 8 over there on the left. I might have to take a little fluid out to get this to work over here on this side. All right, let's add some acid. Drop the pH over here. Here we go. A couple drops of acid. 1 drop, 2 drop, 3 drop. Let's see what happens. How you doing, IAQ? Oh, I missed it. Thank you, J Creates, for letting me know. One of your Alex, one of their favorite experiments is burning different metals and seeing the different. Yeah, that is cool. That's all right, J Create. Don't sweat it. Don't sweat it. I think I'm gonna need to take some of this out so we can get a. We're gonna need a little bit more out. Just try to get a little bit more salt in there, just a bit. Where's my funnel? Right here. It wants to go. I can tell. It's so close. There we go, baby. That's gonna do it. All right. Getting close. All right, let's shake this up and see. Hey, look at that. Future Farm. Donating $1.99. I appreciate that. It's not necessary. Not necessary, but I definitely appreciate it. What happens if this was sprayed on a human or an animal? Probably not a whole lot. Probably not a whole lot. Let me give this a like. Thank you there, Mr. Future Farm. I appreciate that. Shake that thing up. Come on, we got to get some of that salt dissolved in there. Let's see if that works. My day's going good, 11U. Come on, work for me. It looks like, yeah, it's going. It's totally going. It's working. We can focus in on this bottle over here. Come on now. Can you see something going on over there? Something goofy. I see like 3 different layers. See this layer up here at the top? It looks kind of different, like it's a deeper yellow, a clearer yellow. You can kind of see a line right here. There's like a clearer yellow, and there's kind of a hazy yellow. And then down at the bottom, it looks like there's not as much yellow there. No, it's not white. Hey, thanks there, Future Farm. Yeah, it's looking like they're getting 2 different layers at least. At least 2, maybe more. Yeah, I can see 3 layers. You see how this, I see a layer up here. I see a layer right here that's different. And I see a layer down here. Here, to help you out, so you can see these layers a little bit better. Remember, it's just a universal indicator in there, right? And the universal indicator shows these colors at different pH values. So what I'm going to do is I'm going to go ahead and I'm going to add a drop of acid to this so we can see what's going on a little better. Here we go. In goes the acid. So that's going to color red, right? Because that's what the acid does. And look what the acid did, man. It's helping us see the interface between this upper layer and this middle layer. So we actually have 4 layers in this thing now. We have this layer up here. We have the acid layer, and we have this weird layer that's kind of, hey, look at it's thinning out. And then down here we have a lower layer. Hey, thanks there, 11. I appreciate that. I agree there, homeboy. Okay, let's shake this up and see if we can't see what's happening here, okay? I'm going to give this a shake. Before I do that, I need to just take a little bit of this fluid out up here on the top. Just a bit. Just squirt it right in there. It won't matter. There we go. Okay, let's give it a shot. Let's give this a shake here. Now remember, there's a bunch of acid added to this flask. I'm going to shake it up. It is not hot, Panda. Hello there, OB. Welcome aboard. Here we go. Looks like it's not that bottle anymore. Weird. What game is this? This is not a game. We're just doing science together. So I have added universal indicator to this bottle that has an interesting fluid that I'm going to tell you about here in a bit. I'm going to tell you why it has the behavior that it does. But you can see now that the pH in this bottle is like 4 or 5, right? So it's acidic inside the bottle. And as I've shaken it up, look what's happening down there at the bottom. Hello there, John Doe. Welcome back. Toby, how you doing? Thank you there, River. You got it, unbarcoded. Come on now, look at that going on down there. There's like, again, there's these 3 layers. What are the precipitates? That's Esra. That's just some salt that I added to basically do the separation. So what you all don't know is that in this bottle is not just one fluid. In this bottle is some alcohol, which actually is up here at the top, and some salt water. It was alcohol and water at first. It's rubbing alcohol. And then when I add salt, what salt does is it has this effect that we call salting out. And what it'll do, the salt dissolves in the water. And when that happens, the water and the salt particles attract each other so much. It's like 2 people who love each other very, very much. What they do is they sort of date exclusively, or they decide to live together for their entire lives. So that, they're exclusive. And so that's what happens. The salt in the water is exclusive, and it pushes the alcohol out. And what's interesting is you can tell that it also pretty much pushes out the dyes as well. That's all that's going on. Here, let's add a little bit of a base to this. You can watch what happens. This is going to be fun. So we're going to add the base. Now remember, we're at a low pH now, right? We're at like pH 4. When I add base, the pH should go up. So we're going to either get neutral or basic. Let's go ahead and add like, I don't know. Let's add 2 drops of base, okay? Kevin, yes, they're, in a sense, they are, the specific attraction is called an ion dipole force, where the salt provides the ions and the water provides the dipoles. Thank you there, Big. Appreciate that. Thank you there, Italic. Okay, so I've added some base. We've got a low pH. We've got a low pH. I've added the base. That should increase our pH. You'll see what happens here. And remember, we've got alcohol at the top. We got salt water at the bottom, and those 2 don't mix. Here we go. Thank you there, Big. If the pH scale is a measure of how many hydrogen ions are in solution, why does a low pH mean many hydrogen ions and not high pH equal many hydrogen ions? What a great question, the Psi Guy 5. So it looks like I've neutralized. Let me tell you about this. It has to do with logarithms, and logarithms are the base power of 10. The base power of 10. I should say the negative base power of 10. Oh, man, look at that. Some really cool stuff going on here. So pH happens to be the negative log base 10 of the H plus concentration. This is the mathematical definition, all right? And what this means is that if I have a H plus concentration that's 10 to the minus 1, then the pH is 1. If I have a H plus concentration of 10 to the negative 5, which is 10,000 times smaller than this, then my pH is 5. So the pH is just telling you the power of 10 of the negative power of 10 of the H plus ion concentration. And so negative 1, if I take the negative log of that, I get 1. If I take the negative log of this, I get 5. But this is 10,000 times smaller. That's how that works. I know people probably are like, what the heck is this guy talking about? But that's the answer. I do not, Valian. So, hey, we can see here, we can see down here at the bottom, we can see the water layer. Up here at the top, we can see the alcohol layer. And in the middle, you can see a different color there. That different color is what we call an emulsion. An emulsion's a transient mixture, like, when you mix your salad dressing up, the oil and water. They don't stay mixed forever. They separate, and you can totally watch the emulsion layer separating. So what I'm going to do now is I'm going to continue to add base to this so that we can see the color change. Right now we're at about pH 6. Yeah? About pH 6. Thank you there, John. We're at pH 6. Okay? So now I'm going to add some base. Let's add, 2 drops of base. In we go. In goes the base. 1 drop. 2 drops. You can totally see the base right there in the middle. Look at that. Look at that. You can see it, the blue color is what you would expect in a base. But let's give it a shake. It is better times. It's 20% by weight sodium hydroxide. How you doing there, Key? Welcome aboard. Let's give this a shake, see what our pH ends up being, all right? Here we go, man. Here we go. Hey, look at that. We went to green. Now it's blue. Shake and bake. I love it. Here we go. So our pH went really high. This one's going to be fun. You guys, this is going to blow your mind. This one's going to blow your mind. Come on, I see it. I see it. Oh, I'm going to love it if you guys can figure this out. Hello there, Hound Dog. What is going on? Thank you there. Pay attention to Draco Menda. Draco Menda is dropping the pH, the powers of 10. But look at what we got going on here. Now, I agree, Key. It's very cool. Now I have like a blue color here at the top. I have a pink purple color here at the bottom. And in the middle, we have basically, you should understand that's going to be a mixture of these two colors. So what happens at high pH is, I don't tell you this, but one of this dye system that you see over here, it's the same stuff that's in here, it actually consists of 4 dyes. One of them stays dissolved in the saltwater layer. It's usually colorless. It's colorless at pH 3, 4, 5, 6, 7, and 8. If you get it to pH 9 or above, then it turns to that pink color. So that's what's going on there. H2SO4, best party drink. Not going to be drinking it. So the purple on the bottom is one of the 4 dyes. That particular dye, that's the one that, used to be the main ingredient in X-Lax. It's called phenolphthalein. It's usually colorless, but if you get it to a high enough pH, it starts to show up. Not drinking it, Lobo. Not drinking it. That phenolphthalein, that'll end the live in about 15 minutes. Does it revert as well? Let's find out, better times. So what we're going to do is I'm going to add acid to this system. Here we go. That's going to drop the pH. What's interesting about this, here we go. In goes the hydrochloric acid. It's the same acid that's found in your stomach. And it goes, and you can tell that the acid is more dense. It's more dense than the alcohol layer. It's less dense than the emulsion. Look at that. It's floating on the emulsion. Isn't that cool? And then you got the emulsion layer. The emulsion is a mixture of the alcohol and the salt water. So that's the emulsion. And that's transient, so that's separating. And then down here at the bottom, you have the saltwater layer with the phenolphthalein in it. All the other 3 dyes are up here. Hello there, Joseph. Thank you there, Lobo. The Psy Guy, what sparked my passion for chemistry? I grew up in a really small town. We're going to give this a shake. And we're going to see what happens with the pH. So right now we're at a pretty high pH, pH 10. So I grew up in a really small town. And I did not see a science experiment until I went to college. Fortunately, I had the opportunity to go to college. I was a wrestler, and I was recruited to go to school, and I was sitting in a chemistry class, and the professor up at the front did a color change chemical reaction, and my mind was blown. And then what was even more cool is he explained why the color change happened, and something clicked in my head. I was like, holy cow. There's such beauty here, and not only is there beauty, but we can understand it. So, yeah. John Doe, I have worked with hydrofluoric acid. It is nasty stuff. All right, Steve. Steve corrected me. I was just shaking back and forth. Sorry, tipping back and forth. So, yeah. So now we can see I've lowered the pH because I added acid. I agree there, Talik. Here we go. So we've dropped it to like pH maybe 6, maybe 4. You can see the acid layer, the alcohol layer. It's kind of like an orangish. The emulsion, that's the mixture between the the alcohol and the salt water. So we see the alcohol layer, the mixture or emulsion layer, and then the saltwater layer. I can't hold. I'm not a synthetic chemist. Using uric acid would have sped up the titration, says Electric. Let's add a little bit of base to this, all right? Let's add some base, because right now we're at a low pH. Yep, like a pH 4, maybe 5. Golden cheese, of course I remember you. All right, let's add some base to this, see what happens. It does look like mango juice, better times. All right. Not going to drink it. Not going to drink it. There's some phenolphthalein in there. That would end the live pretty soon, man. All right, look at that. You can totally see where the base is. It's very beautiful. The base is going to turn everything blue. You see a little thermal right there. Yeah, little thermal action. So I've added some base to this acid, and when we mix it up, Polo Pronto, this is a pretty complicated experiment, but if you hang out, we're going to be able to explain everything to you. So let's just recap here so people know. Over here, we've got some water with this same dye in it. So we're going to look what happens when I add a little bit of base to this dye over here. Here we go, add a drop. And you can see, wait a minute, when I added base, the color changes. So that's what's going on in these bottles. I have an acid-base indicator, okay? Funny, River. Okay, so that's what I did over here. I have a bottle that's at a low pH, like pH 4 or 5. I added some base. You can see the base, it colors it blue. And now we're going to see what happens when the acid and base react with each other. Have I ever tried to create the Philosopher's Stone? I'm not an alchemist, man. I'm a scientist. Here we go. Here we go. Mixed it. Okay, you got it. John Doe wants me to mix. So here we go. Hey, look at that. There's your color change. As the acid and the base react, it looks like there's more base present than acid. There's an excess of base. I say that because everything turned blue, and that means our pH is going to be like pH 9. So the acid's been neutralized, and we have an excess of base. I agree there, Golden Cheese. Definitely agree. Mix them both. I'm sorry, River, but the flakes are in there because I got to get enough salt in there to get the thing to work. I agree there, Stone Deer. So here we go. What's happening now? The reason why this shows a color now is because there's 4 dye molecules in this system. And it turns out that one of the dye molecules always is in the saltwater layer. It just happens to be colorless at most pHs. However, if you get it to a high enough pH, its color will show up. So you can tell, we're at high pH, everything's kind of blue, and that's when the phenolphthalein shows up. All right, let's add a little bit of acid to this system. You're going to like this. Let's add some acid. Here we go. There we go. No, this would not be safe to drink at any pH because of the phenolphthalein in there. Here we go. Let's add some hydrochloric acid. It's the same acid that's in your stomach. It's just that this stuff is a lot more concentrated. And you'll notice, let's see, I've added like 4 drops of the acid. And sure enough, we can tell the acid is more dense than the alcohol layer. It's less dense than the emulsion because it's floating on it. And it's less dense, of course, than the saltwater layer. The emulsion, by the way, that's a mixture between the alcohol layer on top and the saltwater layer on bottom. I don't have any of that, Moses. John, I don't have any of that either. Let's give this a shake. So I've added acid to a system that contains base. Right now we're at high pH. That should drop the pH. If they're perfectly balanced, it's going to get green, neutral. But if there's an excess of acid, we should see one of these colors here. Let's find out what's going to happen, okay? I don't know. That's why we got to mix it up. Look at that beautiful kind of like nighttime horizon sky. Thank you there, BBY. There's a shake. Oh, man, that was neat. That went through like a whole bunch of different colors. I think we're going to settle at green. I think we are, which means I have balanced the acid and the base. Let's see what this looks like. Let's see what it looks like when the separation happens. Very cool. Hey, give me a like if you want to see me start this from scratch. So if you want to see me start this particular experiment right from the beginning, give me a like. We get, I don't know, what do you say? How many likes should we get to before I show you how to do that experiment from scratch? I'm seeing 88. I'm seeing 88 likes. Let's say 250. Come on, Stone Deer. Come on, Stone Deer. Give me $5. Holy cow. Says, gonna subscribe. I appreciate the subscription. And hey, hope you're doing well. That was your favorite shade of blue. Awesome. I'm seeing some really cool stuff happening in our bottle right now, folks. Check it out. We're at 108 likes. We're going to get here to 250 pretty soon, but this is really beautiful. I don't usually see this, but sometimes it happens. So what we see now is we see the alcohol layer is yellow. We see that the saltwater layer, that is like a slight green, and the emulsion itself is green. What we are seeing now is what we chemists call a solvatochromic effect. Solvent, solvato, I'm not saying that right, but I'm doing the best I can. Solvato chromic. So solvato, that means what solvents it's in. Chromic means color. So the color of the dyes depend on the solvent. If the solvent's in alcohol, it's going to be shifted yellow a little bit. If it's in the mixture of salt, water, and alcohol, it's going to appear green. So the color depends on the solvent. And down here, the dye is basically not present here. Hey, we're up to 125. We're getting close. Getting close. We get to 250. We're going to show you how this starts. Here we go. Let's add a little more acid to this here. Because it actually looks like 4 layers, but I think it's just a lighting effect. This is proof the earth is flat. How about it, man? Don't use anything. Here we go. Let's add a couple of drops of, I'm going to go acid here. 1, 2, 3 drops of acid. The Northern Lights color pH. It is not. What's going on with the Northern Lights is that there are molecules and high up in the atmosphere that gain energy and then give off that energy as light. Thank you there, John Doe. Here we go. Let's give this a shake. Looks like Christmas colors for those that celebrate. Anybody celebrating Christmas yet? For those that do, this bottle's for you. But let's shake it up, because I don't celebrate Christmas until it's after Thanksgiving. That looks like a Thanksgiving color to me. Yeah, a little bit of orange. Maybe more Halloween, yeah, like that jack-o'-lantern color. Merry Christmas there, Lobanova. RRB, you're welcome. Absolutely. We take all types here, man. We take those that do and don't celebrate Christmas. You are absolutely. You are welcome here. That's funny, KD. So it looks like Golden Cheese celebrates Christmas. Put a liquid in it. I don't celebrate it religiously. I know a lot of people do. I do not celebrate it religiously. What color would the pH indicator turn if you added fluorantimonic acid? You know, I don't know, Sci Guy. I'm not sure that the indicator would be able to handle it. So Hold This celebrates Christmas prior to Thanksgiving. All right. Can you explain how fluorescent materials work? Let's do that, all right? Flame, sir, this is a science channel. And let's talk about fluorescent. I want to try this. I'm not sure this is going to work, but we're going to try some fluorescent stuff. Here we go. Here we go. Let's do some fluorescent stuff. All right. So, pardon me. Let's do this. I don't know if this is going to work or not. We're going to try it, though. I see it, Erica. I see you. I love it. Okay. We're going to talk about fluorescent material. So this food dye, because somebody wanted to. So this food dye, it comes from this bottle. I'm not selling this stuff, but it's natural food coloring. And the blue one in particular, if you look at the ingredients, you'll see that it contains spirulina extract. Spirulina is found in like blue-green, I think it is a blue-green algae. And they contain a dye a protein dye, I should say, known as phycocyanin. And phycocyanin gives it its blue color. And it's really cool, man. Phycocyanin is really cool. We're going to do some experiments with it right now. It fluoresces. It undergoes fluorescence. And we're going to show you how this works. So, because somebody wanted to. So let's get this mixed up. I'm going to get this stirring. We're going to put some phycocyanin in here. We're going to watch what happens. Hey, Flame, stop spamming the comments, please. This is a science channel. Here we go. So long there, John. Appreciate you hanging out. Here we go. Let's add some drops. I'm adding the phycocyanin, which is a fluorescent dye. Yeah. Last warning there, Flame. Here we go. Let's add another drop. There we go. If you explain this to people in the 16th century, they think they burned me as a witch. Maybe, huh? Maybe. Okay, let's try this. I'm going to turn this off. In order for us to see this, I'm going to have to turn off my light here. Okay. Turn that off, and now I'm going to shine red light in there. There's UV. Now, let's try it. Hold on. Let's do this. Turn it off. There we go. You see it? There it is. I'm just shining regular old light in there. Turn it off. Look at that. That's UV light, baby. That's just a laser. That's regular light. That's UV light, ultraviolet light, and that's a laser. All right, give me a second. Let's add some more phycocyanin. All right. Here we go. Add a drop. I'm not, Bassem. I'm not. Here we go. Let's add a little drop there. But it doesn't bother me that people are. There's a little bit of a... So what's happening here with the phycocyanin? Uh-oh. There it goes. There's your UV light. And there's your laser. So what's going on with phycocyanin? It is a fluorescent molecule. And what a fluorescent molecule is, it's a molecule that will absorb light of one color and give off light of another. Come on, that's cool, huh? So the phycocyanin, it absorbs orange light really well, because orange is the complement of blue, so it's gonna absorb orange light really well. And then what it does is it gives off the light it absorbs as red light. And it also absorbs some UV pretty well too. So when I shine, turn off the room light, sorry. Thanks. There's the regular light. Okay, come on, that's beautiful. So there's the regular light. So this is just a regular flashlight. So there it's blue. That's the color of the phycocyanin. It absorbs the orange light coming out of the flashlight, and it gives it off as red. And then we call that fluorescence. And it only works when the light is actively on. Now I've got some UV light going. Although my light doesn't work the best. I think the... Yeah, my UV light's not working. There it goes. See, kind of like, look at that. Isn't that gorgeous? God, that's gorgeous. Absolutely beautiful. There it's blue, and there it's red. There it's blue. It's a blue dye that fluoresces red, and it's just absorbing regular old visible light and giving off that visible light as red light. That's fluorescence, folks. That is fluorescence. So it absorbs a light of higher wavelength and emits it as lower wavelength. You have it backwards, John Doe. That's okay. It's energy and wavelength are inversely related. So red light has a longer wavelength than orange light. And so orange light has a higher energy per photon than red light. Come on now. MT. I studied photosystem 2 for my PhD. Come on, baby. Studying that, and I guess you're doing that in biology. I don't know. I got my PhD in chemistry. What's the vase next to the beaker? I'm glad you asked. New music. Let's play around with that. Let's play around with the other beaker, shall we? Make sure that's off. Okay. Let's get these lights on. Make it look pretty. The backlighting looks nice. So what's going on in the other beaker? Let's talk about what's going on in the other beaker. In this beaker, there's something that's different than this blue dye. This is different. So let's find out what's in there. What's in here is something called universal indicator. Universal indicator displays these colors depending upon pH. This is not going to be good for your health to drink. This is no problem. So right now we can see that in this flask, the pH is like 9. Watch what happens. So it's basic. Watch what happens when I start adding some hydrochloric acid, which is the same acid that's found in your stomach. It's just, this is a lot more concentrated. Here we go. Let's add a drop. Hey, look at that. I'm seeing some red. That's because the acid is neutralizing the base. I'm also seeing a color change. I'm seeing the color change. Are you studying the dark reactions there, FG? Erica is a biological technical assistant, but loves physics and chemistry. Love it. So I can drink the drink that glows. Yeah, yeah, you can. Skylar, I am the danger. Come on, I gotta say that right. You want me to say it? I'm gonna say it right. If we're gonna say it, let's do it. Let's do it. If you want it, let's do it. By the way, this is now neutral, yeah? Hold on, I gotta do this right for you. I'm not gonna be able to say it right, but we're gonna do the best I can, all right? Here we go. Skylar, I am the danger. How was it? It work? What do you think? Give me a thumbs up if you liked it. Oh, Moses, I agree. I agree. Let's do a little drop of acid here. Boop, one drop. Thanks there, Talik. Well, my grandpa's name was Walter. True story. My brother's middle name is Walter. No, not making any of that. Not making any of that. I keep it legal around here. Couple drops of acid. Now we're way down. Our pH is way down. pH 3. Yeah. That's right. I'm PG Walter White. Yep. Here we go. Let's add some base here. Let's add some base. Couple drops. A couple drops of base. Oh, I'm adding acid like an idiot. Here, let's try adding the base. Hibiscus tea. Yeah, we got a new jar, Kim Jong. How are the sticks moving? They're magnetic, and they are resting on a magnetic stir plate. So the way that works is the magnetic stir plate kind of has like a spinning fan blade in it that's magnetic. And of course, as that spins, it causes the little magnetic stick to spin. So yeah, the little magnetic stick is an iron core, but it's coated with like a chemically resistant plastic, so you can stick it in all sorts of stuff. The base is 20% by weight sodium hydroxide. Thank you there, Milo. Can I do something useful? Look, man, this looks like art to me. It's like asking, what's the use of music? Some people like it, some people don't. Some people like rock music, some people don't. If it's not for you, you're welcome to move along. How's it changing colors? It's changing colors because I did watch Chernobyl. It's awesome. It's changing colors because there are dyes in here that are sensitive to pH. And what I'm doing is I'm either adding acid or base. Acid lowers the pH. Acid lowers the pH. And base increases the pH. It was, we got our rainbow there, Moses. Let's add a couple drops of acid here. Let's go like 3 drops. You'll see it go from sort of the base pH 8, and it should drop. Thank you there, E. Excuse me. I appreciate that. Thanks there, Talik. I appreciate the vote of confidence. But no, not everybody's going to find this useful. I do. I enjoy doing this. I love doing these experiments for y'all, folks. I hope you know that. I have an absolute blast. All right. How much water would it take to neutralize 1 liter of fluorantimonic acid? So technically an infinite amount. You would need some base, and water is not going to be, water's perfect. Pure water is neutral. What kind of color do you use? Erica, I use what's known as universal indicator. Just add it to the ocean. If you could make the system oscillate on its own, maybe you could put in a thermocouple and temperature-dependent dyes. That'd be fun. I am a couple of weeks. It's either going to be this. It'll either be this coming Saturday. Hey, we got a little rainbow, baby. It'll either be this Saturday or like the first of the year, around the first of the year. I am going to put out a short video on an oscillating chemical reaction that is stupidly easy to do. It's crazy how easy it is to do. And once you see it, you should be able to oh gosh, it's so stinking easy. I'm not sure when I'm going to put it out. I schedule my shorts out, you know, weeks and months in advance. So, but yeah, oscillating chemical reactions are really cool. Every time it oscillates, it reminds me of a tornado touching down. Sure does. Sure does. I'll tell you what, folks. We're getting to the time in the live when things are kind of settling down. And I am going to flip the camera around, and you're going to see an old man in his basement talking to you. If that's not something that you'd like to see, here's your fair warning. It's time to get, you know, go find something else to watch on YouTube Live, huh? Yeah, what's your favorite element? Mine's hydrogen. Thank you there, Random. Thank you there, excuse me. But Sam, I can't keep it up, man. I can't keep it up. I don't know if you just heard that. My wife is watching a football game upstairs, and she just cursed pretty bad. All right, we're gonna do this for you, Bassem, sorry. We're gonna try. We got people liking carbon. Let's try this. Let's show you how this works. Let's show you how this particular one works. We'll see. We'll see if we can get back up to around 500 or so. All right? Who knows? Who knows? We're going to give it a shot. We're going to start this thing right from the get-go. So right here, I have a little bit of water. And to this water, I'm going to add, no, let's not add the salt yet. Let's go ahead and add some alcohol to it, okay? Here we go. In goes the alcohol. So this is water, and the alcohol I'm adding is just 91% isopropyl, okay? In it goes. In it goes. Get a nice mixture. That's probably going to be good right there. All right. We're going to mix it up, and we're going to see here. Let's add a little bit of universal indicator. If we add that universal indicator, it's going to allow us to see whether these two mix together or not. Funny there, Terada. Here we go. Let's add the universal indicator. In it goes. That's probably enough. All right, and we're going to give this a shake. And if that color uniformly goes through the entire bottle, the entire fluid, then we know that we have what we say is miscible liquids. Miscible liquids are liquids that mix in all proportions. So let's go ahead and here we go. Let's give this a shake here. And it looks like the green dye has went through the whole solution. That tells us we have a single uniform liquid. It's a mixture of alcohol and water. We've got a mixture of alcohol and water. Now what I'm going to do is I'm going to add salt to this. So I've got alcohol, I've got water, and now I'm going to add a boatload of salt. We're going to add some salt, baby. Here we go. Here we go. This thing's going to get sick of salt. We're going to add so much. In it goes. In it goes. And just to make sure I got enough, I'm going to add a little bit more. Just a bit more. Just really add this. Oh, I had so much it almost overflowed. Okay, so we've got alcohol, we got water, and we got salt, and we're going to see what happens. Here we go. There we go. Shake. Oh, man, you can just see there's a bunch of salt in there. I have added a bunch of salt. Speaking of the hydrogen, how does the electron not fly off? If it's attraction to the proton balance with the speed traveling, but then what about the electron being a wave? Does it matter? I think you answered the question there. You know, you can kind of think in the hydrogen atom, the electron has a balance of potential forces, the proton attracting it to the nucleus, and kinetic forces, which is going to be, you know, it's motion around the nucleus. And if those forces balance, then you're going to have a stable atom. And it does fly off a lot, indeed, Mr. Tease. Yep. Okay. Let's see if this is enough. I don't know. Let's find out. Is it going to work or isn't it? Oh, yeah, it's totally working. It's totally working. So what happened now? Is there any set of conditions where a specific acid becomes better at donating protons? Yes, absolutely, the Psi guy. So For example, if you put an acid in water, it's going to donate protons to the water. But if you stick that acid, say, in the presence of a base that's stronger than water, it's going to donate its protons even better. So what happened here? So I added some salt to a mixture of alcohol and water. When this happens, the salt dissolves in the water, and the salt ions and the water molecules, they attract each other so strongly. It's like two people when they fall in love and attract each other very strongly. They attract exclusively. So they, in a sense, date exclusively, and they push all others out. And that's what we saw here. We saw the salt and the water. That's salt water here, and it pushed the alcohol out. So in a sense, though, the salt in the water is dating exclusively at this point. Talc, I'd have a really bad afternoon, at the least. Yeah, one of the indicator dyes used to be the main ingredient in X-Lax. So at the very least, I know that the live would end in maybe 10 or 15 minutes at the least. Okay, we're going to add some base to this. Why? Because that's what we do here. We mess around. So I am going to add some base to this, a couple drops. And you can totally see the base right here. It's more dense than the alcohol, less dense than the salt water. Nice, MTZ. I agree. But Talc, you could do this with other things that aren't quite so bad. So I'm going to shake this up. We know that we have, it's sodium hydroxide, Erica. So we've got a pH 6, which is yellow. I've added base to it, so our pH is going up. We're going to shake this up, see what happens. Here we go, baby. Give it a shake. It's looking green. It's now looking blue. It's now looking violet. What in the heck is going on? Hey, look at that! What in the world? How did that happen? Base is alkali. We use that synonymously here in the United States. What the heck just happened? Absolutely you could, John Doe. Right there, excuse me. So what's going on here? There's actually 4 dyes in this particular system. One of them is colorless at low pH and becomes colored at high pH. So that's why we see that pink color show up when it's quite basic. It is cool, isn't it? It's beautiful. Very cool. All right, let's flip this camera around. I'm going to talk to y'all. And I've had enough for one day. Definitely had enough for one day. Apologize, but I'm getting close to an hour. It's about all I can handle. So this is going to get flipped around here. Take off if you don't want to see me. Thank you there, Jacob. I appreciate that. Alkalizer base. That's fun. Thank you, Maria. I appreciate you hanging out with me today. Had a great time. Had an absolutely great time. Thank you there, Milo. Appreciate that. What's the most counterintuitive chemistry fact that you know? The most counterintuitive chemistry fact that I know is that in order to be 100% certain that you know where the electron is in a hydrogen atom, you have to consider the entire expanse of the universe. If the electron is at one end of the universe, its nucleus could be at the other. Now, the probability of that happening is so vanishingly small. This is how we get rid of the counterintuitive part. The probability of that happening is so vanishingly small that I would bet everything that I have that I would never see that occur. But always a chance. There's always a chance. Maria, my background, I have a master's and a PhD in chemistry. Thank you there, Talc. I appreciate that. Thank you there, new musician. Hey, it's just a mathematical thing. It's just the same thing as like the Gaussian distribution, the bell-shaped curve. It just means that the probability asymptotically approaches 0. So, I mean, as you go further and further out away from the nucleus, the probability never hits 0. It just asymptotically approaches it. So, once you learn that, you're like, it ain't that big a deal. How would you test for a decrease in electron speed when you apply a magnetic field to it? How do they test for electron speed? That's a good question, because I know they do that in the photoelectric effect. Yeah, science, BB. Kim Jong, I hear that, but that's not going to happen to me if I can help it. Hey, all right, Manuel. All right. Oh, no, absolutely, Talik. Rocks and minerals are really cool. Absolutely, I think they're cool. You know, they're made of ionic compounds, like your teeth. They're like rocks, man. You know, they're these, it's like we got rocks in our mouth. Hello there, BB. Maria, I do a lot of experiments with different types of water. Thanks here, Talik. Feldspars. Give me the chemical formula of feldspar. That's got calcium in it, doesn't it? Calcium silicate. Hydroxyapatite, Ratchet. I've been noticing you there in the comments, Ratchet. You're definitely a chemist, or somebody who works with chemistry. Same reason why rocks break a lot of time, Mark. So long, Bassam. Thanks for hanging out. So long, Bassam. All right, folks. I'm calling it a day. Calling it a day. I did not know that. Excuse me, sir. SNRPS enzyme. Never heard of it. I got to look it up, though. Got to look it up. Hey, thanks for hanging out. Upcoming week, I got some homework for you. The homework is spend some time and look at the beauty that's around you. It's always there, man. Like it's always there. Spend a little time, pay attention to it, and think about the science behind it. That makes it even more beautiful. So long, folks. We're going to see you next week, right around this time. Great hanging out with you today.